So number 10 in the Sapling homework for chapter 15 will give you a variety of different questions. All of them will require the use of the quadratic equation. But the question that I got when I pulled up problem 10 was I was given this equilibrium situation where I have hydrogen sulfide gas decomposing to hydrogen and sulfur gas. I was given a Kp value for this reaction of 0.761, and I was told that the initial pressure of hydrogen sulfide was 0.122. So my initial concentration of my products was 0, so I know that my reaction has to shift to the right to get to equilibrium. So my change is going to be minus on my reactant side and positive on my product side. And since my stoichiometric coefficient is 1, each of my x's has a stoichiometric coefficient of 1. So down here, my third row of my ICE table is the sum of the first two rows. Now I'm going to plug in my equilibrium pressures into my equilibrium expression. So pressure of hydrogen is x, pressure of sulfur is x, and the pressure of hydrogen sulfide is 0.122 minus x. Now what I want to do is I want to simplify this so I can get it in the standard quadratic equation form. First thing I want to do is I want to eliminate the values in my denominator here. And I'm going to do that by multiplying both sides by the denominator. So when I multiply this side by the denominator, I eliminate it in the denominator. And then when I multiply this side of the equation by my denominator, I'm going to have to distribute 0.761 over the terms in the original denominator. So I just rearranged it from here so it's easier to see what I'm distributing. So when I multiply 0.761 by 0.122, this is the value my calculator gives me. And when I multiply 0.761 by negative x, I get negative 0.761 multiplied by x. Now, what I want, as I said earlier, is to get this into standard form. That means I want all my terms on one side of the equation and 0 on the other side. So I'm going to choose to leave my x squared here, and I'm going to get these two terms on the same side as my x squared. So I'm going to subtract 0.092842 from both sides of the equation, and I'm going to add 0.761x to both sides of the equation. So when I do that, I get 0 is equal to x squared plus 0.761x minus 0.092842. So this is now in standard form for a quadratic equation, which means I have a variable to the second power. I want the highest power first, the power of 2 first, and whatever coefficient is in front of x, that's going to be my a. And then my x to the first power to be second, and whatever coefficient is in front of x, that's going to be my b value. And then my last term is going to be just the number that's not being multiplied by my variable. So once I have it in standard form, once I've done all the algebra just to manipulate this equation into standard form, now I can see what my a value, what my b value, and what my c values are. So a is equal to 1, b is equal to 0.761, and c is negative 0.092842. So here we are. Here's my equation, and that's how I was able to get a, b, and c. So now that I know what a, b, and c is, it's merely a matter of carefully plugging my values in. Here's the quadratic formula. So negative b would be negative 0.761. B squared should be negative 0.761 squared. I forgot the negative there, but when I square it, that negative is going to disappear anyway. And then I'm going to subtract 4ac. So 4 times 1 times negative 0.092842, which was c. So in the square root symbol, when I square 0.761, that's what I get. And when I multiply 4 times negative 0.092842, I get a negative number, and subtracting a negative number becomes addition. So this is the final value that I get in my square root sign. And when I take the square root of it, I get 0.97493, and I add that to my negative b, which was negative 0.761. Now, I didn't even begin with subtracting my discriminant from my negative b, because since my negative b is a negative value, if I were to subtract something from that, I would just get a negative value for x. And I know that a negative value for x is not an answer for my problem because I can't have a negative concentration. So I knew that the only answer here was going to be what was added to my negative b. So then I continue my math, and when I add my numerator values together, this is what I get. And then when I divide by 2, I get 0.106965. And what my question asked for was the total pressure in the flask. And so the total pressure in the flask is just going to be a sum of all the equilibrium pressures of my chemicals. So remember way back when, my ICE chart, the pressure of my hydrogen sulfide was my initial pressure minus X. So now that we know what X is, I subtract X from 0.122, and here is my equilibrium pressure of hydrogen. And the equilibrium pressure of hydrogen and sulfur are equal to X, and that was that. And here's the value that I solved for. Now, before I go any further, I want to make sure that these values are correct. I'm going to plug them back in to my Kp expression, my equilibrium expression, and make sure that I get my original equilibrium constant back, and I do. Hooray! That means all this work paid off. And then to calculate my total pressure, I just add my equilibrium pressures, and then this is the answer that I get.